Hi, YouTube. My name is Frank. I'm going to talk to you about air-powered pumps, well pumps. And this is a small version. This is a 2-inch pipe with some fittings, so this is a slightly less than 3 inches in diameter. We call this the Kronos, and the reason we call it a Kronos is because it has these two little fittings here which look like little antennae, and they kind of match the robot that was in a 1957 movie called Kronos. And if you ever get a chance to watch it, it's pretty good for its time. So anyway, the reason we do air instead of electric is to prevent the problems with electricity. One, you don't have a lot of moving parts in it. We have two moving parts. We have a check valve in the bottom, and we have a check valve in the top. And they're pretty solid things, and they should last a long, long period of time. So the only thing that could make you pull this out of the ground are a failure of those two parts. You don't have electricity, you don't have wires, you don't have bearings, you don't have things spinning at thousands of RPM. So it's very reliable. Now, it doesn't put out a lot of water, but it puts out a lot of water if you pump it for a few hours a day. So there's some trade-offs here. If you want all your water in 10 seconds, well, get yourself a 15 horsepower pump. But if you want something that'll operate for a couple hours a day and supply you and your family a little bit of livestock and a garden, this is it. The other thing is, this pretty much is immune from the problems of major disasters. One being solar flares, which can come in and destroy electricity, motors, generators, all kinds of transformers and stuff. It can take out the grid. In fact, I'll be talking about this later, but it's happened before. Back in 1859, there was a big one that lasted for 2 days, and the only real stuff that was out here was telegraph, and it actually set things on fire, and it was a pretty major event, and I'll talk some more about that later. Also, back in I forget the exact date, but up in Canada, they had a solar flare that hit them, and it didn't hit the rest of the world. Thank goodness, and they were out of electricity for some period of time. In fact, there were major generators in some of their hydroelectric dams that were out. They were completely taken out because of the energy that was backfed into them. So this being air-powered and only having water lines going down here, nothing's going to come down and injure this. It just won't happen. It's non-electronic. It's non-electric. So all those issues dealing with waves and energy fields and that kind of stuff, it's just not going to affect it. Now, what happens on the surface, that where you get your air, we'll discuss that in some more length as well at the end of the tape. But for right now, what we'd like to do is like to show you this thing working. So we're going to take this down. There's a couple miles from here. There's a water cut gorge, and it's about 80 feet deep. And what we're going to do is we're going to take this thing and we're going to put it in this canister right here, fill it up full of water, and you'll see it at the bottom of the ravine. And then we're going to, using compressed air held in a tank, we're going to pump it up the ravine and show you that operation so you get a feel for this particular technology. And then after that, we'll chat some more about why doing this and what are the advantages and why I think a lot of these should be all over the United States, in fact, the world. And one of the major things is its cost. This whole system is really inexpensive. Very reliable, inexpensive, and pretty much immune from the major electrical disturbances that might occur on the Earth. So without further ado, let's switch over and see the actual demonstration. that's only about 40 psi. Let me go check. It's about 40. I crank her up to 50 on the cycle. Yeah. Squirting out a little more?
Yeah, it's looking good.
Oh yeah, there you go.
Yeah.
Yeah, that's a good cycle right there. This is the controller that times the pressure on and off and the exhaust. You just heard the exhaust. So we have a pressure cycle. And this is the exhaust, so it exhausts the air out of the line so that the water can fill up the pump down below. Then it goes through a pressure cycle. And we've got water squirting out of the hose. Simple. The parts have been around for many, many years. You can expect years of operation out of all this stuff. You just got to keep it clean, keep dirt out of it. On your airlines, you should have a clean source of air. Just have a filter on it. If you do that, you should get water out of your well for a long, long period. The only thing that's down in the well are 2 check valves, so it's possible that you can have this thing operate for 20 years and never have to pull it out of the ground. There you go. Good screen right there. And we got a pressure cycle. Exhaust cycle. Well, here we are. It's the end of the day. We did our test, and I want to point out a couple things. One is that the pump, in a 2-hour period of time, will fill these 3 drums. And we figure that those 3 drums coming out of your well will take care of your family. And because we're using air power, it should be a safe, reliable method of getting water in an emergency into your hands. And what we're going to do is on a follow-up video, so just look for the number 2 and click on it, and I'll give you a lot more reasons as to why we're doing this and where the movement is for those seeking to have a safe, reliable source of either food, energy, water, whatever, into the future, no matter what kind of natural or man-made events may transpire. So I will talk to you again when we do that. I'll sign it off.